practice test with you here. I won't do the last two because I did them with my wonderful B group on Thursday. But the very first problem on your test, you will be asked to solve by graphing. Remember, a solution to a system of equations is a point that works or makes each equation true. So it actually ends up being the intersection point, if there is one, because that's the only point that's on both the lines or makes both equations true. So we're in search of that intersection point. To graph this one, I know that the slope is a half because this is in the form y equals mx plus b. And I know my y-intercept is 2. So this one's set up beautifully for me to go to my y-axis. So make sure you go to your y-axis. I'll go to 2 on it because my y-intercept is 2. And from there, I'll slope it out by going up 1 over 2. All right, so I have my y-intercept of 2, which has been plotted. And from there, I'll go up 1 over 2, up 1 over 2. It helps to kind of slope it out kind of across your whole grid. So that's the first set of points that I'm going to connect to make the first line. So this guy is done. Now what I'll do in blue is I will go take and graph the second line. Now there's 2 ways to graph this second line. Some of you like to use the zeros because they're so easy to find for this one. So you'd plot 0, 5, and 5, 0, and you'd connect as straight as you could. Some of you, which I think is safer, just so you can slope it out all the way, like to solve it for y. And remember, because that's a positive x, you need to move it over as a negative x. You need to do the opposite. So again, we have that y-intercept of 5, and I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Notice I do land on that other y-intercept by sloping it out. My solution to the system is the one point that's on both. Now, if they ran parallel to each other, there would be no points on both, and we would write no solution. If I graphed one of them and it collided entirely with the other one, then we'd say there's an infinite number of solutions. But most of the time, there's one solution, and it's the intersection of the 2 lines. So then after you did that, you did substitution and elimination. And this is, you can use either or. So when one of the variables is explicitly solved for, it says y equals, or it says x equals, you'll want to use substitution. When that doesn't happen, like over here on number 3, it does not say x equals or y equals. That's when you'd probably gravitate towards using elimination. So for substitution, we take what the y equals and we put it in to the other equation for the y. Hence the name substitution. We're going to sub it out with something that's equal to it. So we'll say 3x plus twice the y. But this whole chunk is going in for my y. That has to equal 7. We'll distribute the 2 in carefully. We'll have 3x plus a negative 4x plus 6 is equal to 7. 3 of these plus negative 4 of those or minus 4 of those gives you negative 1 x's. We subtract 1 from both sides. We divide by negative 1, and we get x equals negative 1. Be careful you don't quit here, because that's what the x is equal to. And remember, we're in search of intersection points. They need an x and a y. So my answer is negative 1 comma, and I need to go find it by taking that x value, traveling up to the very beginning of the problem, and putting it in for x. I like to put it in the one where it's already solved for y, because it's less work. It says to get the y, I need to do negative 2 times the x value, which is negative 1 plus 3. This would be 2 plus 3, or 5. Now, the beauty of these is you can check them, and this isn't a very long test. You're going to have time left at the end. So what you might want to do is take the ordered pair and put it into the other equation and make sure that it works if you have time. What I mean by the other equation is I already plugged the -1 into the top equation. So I know it works in that one, but just to make sure I didn't make any arithmetic mistakes, maybe you might want to go to your calculator and do 3 times the x value that you found, plus 2 times the y value that you found. See what it equals. -3 plus 10 is 7. So I'm 100% sure I'm going to get 100% credit on that one. Next one, number 3, I'm going to choose the elimination method for 2 reasons. Like I said, it doesn't say y equals or x equals, and I have to solve for it, and that's going to get messy. And furthermore, I noticed the elimination method is when your goal is to add the 2 up to wipe out a variable, or that's why it's called elimination. You want to eliminate one of the variables. Well, this one's set up beautifully because the x's go without me doing a thing. Now, well, let's go do that one. So 2x's plus -2x's is 0x's, and they're gone. 3y's minus 1y is 2y, or plus a -1y. 8 plus a -12, or 8 minus 12, is -4. And y pretty much just falls in my lap here. And I get a y value of -2. Okay, so I'll take that, whoopsie, sorry. I'll take that -2. I'll put it in my answer in the y slot. So make sure you get it going in your right slot. And then I'm going to go back up and put it in for y. Now my A group asked me, well, how do you know which equation to put it in for? And I said you can put it in either one. I like to choose the one with fewer negatives because I think you're more likely to make a sign error when you have all those negatives. So I'm just going to say twice my x value plus 3 times my y value, which I found to be a -2, has to equal 8. So I'll have twice x minus 6 has to equal 8. Back to little algebra 1 here. I'll add 6 to both sides. I get twice x equal to 14. Divide both sides by 2, and I get x equal to 7. All right? So had I graphed those, they would have intersected at 7 to the right and 2 down. For the word problems, you're generally working with 2 things. Whether you're buying them, baking them, whatever, there's usually 2 nouns in this problem that you're working with. So this is a store that sells school supplies. It sells pencils that you're buying, and you're also buying notebooks. So the 2 things in this problem are pencils and notebooks. Another way to sort of, here, I think I deactivated my, there it goes. So those are the 2 things, and it's always in the question too, and it says how many packs of pencils and notebooks. Those are my 2 things. I would call one of them X and the other one Y. Generally for these problems, you're told how many you have. I buy a total of 7. Well, I bought 2 things. I bought notebooks and pencils. Maybe I had 7 pencils and no notebooks. Maybe I bought 1 pencil and 6 notebooks. Maybe I bought 2 pencils and 5 notebooks. Or maybe I bought 6 and 1. We don't know, but we do know that we have 7. So we do know that x plus y has to equal 7 for a grand total. But like it says over here, that's a whole lot of options. There's only 1. Right? I walked out of that store and I either had 2 and 5 or I had 6 and 1 or I didn't buy any notebooks. So how do I figure out which one of those pairs it is? Or maybe it's 4 and 3 or 3 and 4. I don't know. Well, they told me how much money I spent. So it said that they're $1.50 for every pack of pencils. And my pencils are X. In addition, $2 for every notebook pack. So I also know I spent $12.50. Now I have 2 equations. By the way, you'll learn in higher levels of math that you need as many equations as you have unknowns. In this problem, I have 2 unknowns, so I needed 2 equations. Now that I have them, I have to decide, do I want to use substitution or elimination? And again, that's up to you. This one, although it's not solved for y, it'd be easy to just say y equals 7 minus x. So that's totally an option for you if you want to go with substitution. The kids in the A group, when we did this in class, they saw elimination, and I said, okay, so I'm going to do it with the elimination. I said, if you're going to do this with elimination, you can't just add them up, because if you add up 1x and 150x, you get 250x. And 1y plus 3y, nothing eliminates. You need a pair of opposites. So I asked them, I said, well, what should I do here to create a pair of opposites? And somebody told me, one of the girls said, let's multiply the top through by a -2. Understand why she said that, though. Why would she tell me to multiply the top through by -2? It's because if I had a -2y here, I'd eliminate the y's when I add them up. Make sure you multiply everything through by -2. This term, and most importantly, because it's the one kids forget, this one. So I'm going to rewrite the top one. All the black stuff multiplied by -2 will give me this new equation. The bottom, I'm going to leave undone. I'm not going to do anything with it. I don't need to. I can eliminate the y's by not messing with that bottom equation. So I'll say 150x plus 2y is equal to 1250. So notice on this one up here, the x's naturally eliminated themselves because they were already opposites. For this one, I had to create a pair of opposites. Now when I add these up, I go to my calculator or in my head and do -2 plus 150, and I get -0.5. The y's are gone. When I do -14 plus 1250, I get -150. And when you divide that should be an x right here. When I divide by what's in the way, so when I go to my calculator and I do -1.50 divided by -0.5, it'll tell me x is 3. Equivalently, it means the pair that I bought was I had the x, which is the pencils, are 3. Well, then how many notebooks did I buy? It had to be 4. Because again, back to the original, I bought 7 things. So my ordered pair, that's the solution, would be 3, or you would say 3, 4, or 3 pencils and 4 notebooks. Next. Now we started graphing the inequalities. So notice this is very similar to the first question we did, where we graphed those 2 lines and we said this is where they cross. We will still be graphing 2 lines, but the inequalities indicate that there's shading, that there's an infinite amount of solutions, not just one. If I said y is greater than 1, what is it? You'd say 2, 4, 7, 119, a million, pi. I don't know, there's so many, right? So there's a whole bunch of them. And we need to find the region where they all lie and shade it in. But it's basically the same as when we did it with the equals. We still need to graph this line. It will be dotted because of that greater than, not greater than or equal to. So we'll have a dotted line. It's in slope-intercept form, so I know its slope is -2 or -2/1, and its y-intercept is -5. So when I go graph this line right here, I will go to my y-intercept, y-axis, y-intercept. Done. I'll go down 2 over 1, down 2 over 1. Maybe I want to go up 2, back 1, up 2, back 1, up 2, back 1. I would do that quite a bit, and then we'll draw our line nice and neatly, as neat as you can, right, on a big old smartboard like this. But there we go. So then next up, I need to graph the other one, but it's not a line. It has those absolute value bars, and you did that last chapter, and we know that those make, a lot of kids just call it a V. And I asked the kids in class yesterday, I said, well, do you think it's going to be like that, or do you think it'll be like this? And they did know it was like this, but just in case you don't know why, from last chapter, it's because of that negative right there. So again, I'm going to go change colors, and we're going to deal with that absolute value inequality in blue. All right, so I know it's going to make an upside down V. I know I'll be shading, right? So what I need to do first is find that vertex, because that locks me in. The vertex is a point. Somewhere on this grid over here lies the vertex of that parabola. And it's at the opposite of this, or whatever makes that 0, which would be 1. You might want to think of it as x minus negative 1. I don't know how you want to think of it, but it's x minus 1, so it's a 1. But I like to tell kids whatever makes that 0, and then whatever's being tacked on. Okay, so 1, 2 is the vertex of my parabola. Now it opens down because of that negative. Think of it as like the slope. This went down 2 over 1. For this guy, I'm going to go down 3 over 1. So I'll go down 3 over 1, down 3 over 1, and symmetrically about the other side. All right, I will do that solid. And then we have to talk about purposely some mistakes I made. I'm going to move on to the next problem. No, you don't, because there's a couple things wrong with it. First of all, when I first started this problem, I said there's shading. And that's what some kids forget to do, is the shading. They get so caught up in the graphic. I need to be greater than or above that first line. So I'm going to go take my blue and shade above that black line. So over here are all the solutions to the top linear inequality. Anything above the line. But I also need to stay, I'll do it in purple, below, because of the less than or equal to, the absolute value. So I'm in here. Now anywhere where you see that pink change colors is where our solution lies. So you'll notice I'm above the black line and below the blue absolute value in here. You need to make sure you shade that really well so your teacher knows. Now there's still one thing wrong with mine. And if this was worth, say, 5 points, your teacher's going to go 4 or 4.5 out of 5. And I'd like you to think about it. Just look at it, look at what I wrote, and look at what I did. And I purposely did it. I purposely left the shading off at first because kids forget about the shading. So remember, whenever you have these, you better have some shading. Also, that was just greater than, not greater than or equal to. So my original line, I was so excited graphing it that I neglected to show my teacher that I know that that's a dotted line. So make sure you have all those details on there. And then this one right here, what points are part of the solution? Now I'm not sure if they want you to just say A, because that's where that darkish shading is, where we're above one of them, above the dotted one and below the solid line, or maybe if you're asked to list, again, I'm not exactly sure, it might say list 3 points like it did on your homework that are in the solution. Well, then you can pick any 3 of the infinite amount that fall in this really dark shaded region over here to the right. And these, you can see there's writing all over it because this was already recorded with the B group on Thursday. So if you make sure you know how to do these 7 or 8 problems, you're going to rock this test. All right, you guys have a good one and enjoy your weekend. It's great working with you.